आज के इस लेक्चर के माध्यम से रैप अराउंड डिजाइन ऑफ रैप अराउंड जियोटेक्सटाइल reinforced अर्थ रिटेनिंग वॉल के बारे में, जिसे आई वॉल भी कहते हैं, इसके बारे में स्टडी करेंगे। वी कैन सी द जियोटेक्सटाइल, ये आरी वॉल हैज बीन कंस्ट्रक्टेड विद द यूज ऑफ जियोटेक्सटाइल, रैप अराउंड जियोटेक्सटाइल। इसको हम डिजाइन कैसे करेंगे इसके बारे में पढ़ेंगे। इसका जो पैरामीटर्स दिया गया है वो इस तरह से है कि हाइट ऑफ वॉल इज 6 मीटर, and surcharge weight is 10 kPa, means 10 kilonewton per meter square, and unit weight of soil, जो इसमें selected soil fill की गई है, that has unit weight of 18 kilonewton per meter cube, and then जो angle of internal friction जो दिया गया है phi equal to 36 डिग्री दिया गया है, and the cohesion of soil is 0, and जो टेक्सटाइल यूज की गई है उसका अल्टीमेट टेंसाइल स्ट्रेंथ इज 50 किलो न्यूटन पर मीटर है, टी अल्टीमेट, एंड द एंगल ऑफ फ्रिक्शन बिटवीन द सॉइल एंड द जियो टेक्सटाइल जो लेमडा है दैट इज 24 डिग्री। टाइप ऑफ वॉल रैप अराउंड, फैक्टर ऑफ सेफ्टी इज यूज्ड 1.4। reinforcement orientation perpendicular to the wall, जो reinforcement का orientation है that is perpendicular to wall, so we need to design this for the internal stability in this lecture. So first of all we need to find out what is the coefficient of active earth pressure, Rankine coefficient of active earth pressure, that is given by 1 minus sin phi divided by 1 plus sin phi, and phi is nothing but 36 degree given in the problem statement itself, upon 1 plus sin 36 degree, and sin 36 degree is 0.588, substituting 1 minus 0.588, 1 plus 0.588, so 1 minus 0.588 is 0.412 divided by 1.588, so the value of K has come 0.259 or say 0.26. This will be used elsewhere in the providing the solution of this particular wrap around geotextile wall. Then we can see this is the active zone. It will be this Rankine failure plane will be inclined at 45 degree plus 5 by 2, 45 degree plus 36 by 2, hence 45 degree plus 18 degree, and that is 63 degree. So it is the failure plane is inclined from the base is 63 degree, and from the vertical it is 27 degree. So and the surcharge weight is Q is equal to 10 kPa. Having find out this, we should determine what will be the pressure at the base, क्योंकि सबसे ज़्यादा स्ट्रेस इस लेयर पे होगा. So we can find out what will be the pressure at the base. Generally 5.5 पे पहली जो टेक्सटाइल होगी, but for all calculation purpose we can go for with the extreme. So sigma h horizontal pressure at this will be sigma h will be K times sigma h will be Ka times normal stress sigma b plus K times surcharge Q, Ka sigma b plus Q, and sigma v is nothing but unit weight of soil into depth. Here we take extreme fiber, say at depth z plus q. Now we know the value of K is 0.26, value of K is 0.26, unit weight of soil is 18, and the depth is depth well, at the base Z is equal to H 18 into 6 plus Q is surcharge weight, that is 10 kilonewton per meter square. So solving this 0.26, 0.26, 108 plus 10, so it will come 30.68 kilonewton per meter square. The pressure at the base of the wall will be 30.68 kilonewton per meter square. Now we use the reduction factor to be more safe. जो हम reinforcement यूज कर रहे हैं, जो टेक्सटाइल यूज कर रहे हैं, उसमें हम लोग reduction factor कंसीडर करते हैं. For the creep 1.5, installation damage factor 1.2, durability factor 1.1, and factor of safety 1.4 is given. So total reduction factor is 1.5 into 1.2 into 1.1, so 1.98. So reliable tensile strength TLO, the geotextile what we have in the problem is having 50 ultimate tensile strength 50 kilonewton per meter. Now reduction factor 1.98 and the factor of safety 1.4. So 50 divided by 2.77, it will come as a reliable geotextile strength attained is 18.05. We can see the calculation also. 50 divided by 1.98 reduction factor and again divided by 1.4 factor of safety. So it has come 18.03, 18.0375, 18.0375, or we can say 18.05 kilonewton per meter. After application of the reduction factor, so geotextile का जो safe ultimate reliable tensile strength है इसमें, that has come 18.05 kilonewton per meter. Now we need to find out what should be the spacing. जो हम geotextile use कर रहे हैं, what should be the spacing? So consider the spacing SB at the bottom. So yes, spacing at the bottom जो हम मान लीजिए इस reinforcement को ले रहे हैं, तो unit length of this reinforcement layer will try to pull this geogrid towards the wall, because in case of active earth pressure their failure will be towards the wall. So sigma b into horizontal जो lateral pressure होगा, that is sigma h, will be T allowable. Now we know the T allowable is T sigma v, sigma h we have calculated, that is 30.68, 30.68. So at this layer SB is equal to 30.68 and allowable we determined 18.05. We can find out the vertical spacing between the geotextile layers. So SB will be 18.05 divided by 30.68 is nothing but 0.588 meter. Means the spacing for this geotextile, which is having after reduction factor allowable tensile strength 18.05, we can safely place at interval of 0.588 meter. We can check for the intermediate also, but for the calculation purpose we can check for this, and once we know the optimum layer जो vertical layer होना चाहिए, दोनों के बीच में जो spacing होना चाहिए, that should be provided. But here it has come 0.588. Now in IS code it is given that the spacing as less, that will be more safe. So reinforcement should ensure adequate stress transfer. Smaller spacing is preferred. Wrap around flexible fascia system. Adapt SB is equal to, now since it has come 0.588, so to be more safer, the vertical spacing between the layers has been considered in this problem 0.50 meter. Now it is 0.50 meters and wall height is 6 meters. So number of layer will be required 6 divided by 0.5, 12 numbers. Tensile force in the reinforcement. Since sigma h is 30.68, sigma h is literal sigma is 30.68, and the spacing now revised sigma SB is 0.50. Now by multiply we can know the how much the stress, tensile stress in the reinforcement. So 30.68 into 0.5, 30.68, 30.68 into zero point 0.5, it has come 15.34 kilonewton per meter. So now we can find the tensile rupture check. Requirement T allow is 18.05 and T maximum due to vertical spacing between the geotextile layers 0.5, it has come 15.34, safe against the tensile rupture. Means if it has become reduction factor के बाद में still it is showing only 15.34, hence it is more safe. Now we need to find out the reinforcement length. Reinforcement length should be generally given in the IS 15891, that it should be 0.7s to 0.8s. Considering 0.7, height of the wall is 6, so 4.5 meter, 4.2 meter. Now we provided the 4.5 meter, provide reinforcement layer of minimum length 4.5 meter. Now we can check whether this length considered is adequate or not by determine the anchorage length कितना चाहिए and the active zone का length कितना चाहिए. दोनों को ऐड करने के बाद we will find out how much the length required and how much length we have provided. If the provided length is more than the required length, then structure is safe. So here determine the length of fabric L using equation LE with the lambda value 24 degree and C is equal to 0, failure plane. So we can find out the, if we consider this one, so it is at 5.5 meter below. So we can find out what should be the length in the active, that is LR, in active zone. So LR is equal to nothing but this LR, this is LR upon this is equal to this angle tan 27 degree is equal to LR over this length. This length is nothing but h minus z, means that is LR is equal to 6 meter minus 5.5. It has come LR over 0.5 tan 27 degree into 0.5 will be the length required in the active zone, which will not serve any strength, but this will be uh, pulling this reinforcement outside due to active pressure. So this has come the value of LR we can 6 minus 0.55 tan 45 minus 36 degree upon 2.5 tan 27. So this length has come 0.255. This length has come. Now we need to find out how much how much will be the LE, anchorage length. How much is nothing but LE is, we can find out LE into 2 times जो स्ट्रेस होगा, 2 times shear stress equal to SB into sigma h into factor of safety, that is that is nothing but 1.4. So SB is 0.5, sigma is 30.68, and this factor of safety is 1.4. LE is equal to LE into 2 times stress, and that this stress is nothing but tau is nothing but C plus sigma tan lambda, and C is equal to 0, and sigma, this sigma vertical is nothing but gamma unit weight into Z. Tan lambda is tan 24. So we can input the detail. SB into sigma h into factor of safety 2 times sigma b tan lambda, 0.5 spacing, vertical spacing between the geotextile is 0.5. The lateral strength, जो lateral pressure है on the wall is 30.68, factor of safety 1.4, 2 into and 2 into sigma with unit weight of soil into height, that is 6 meter, or we can take 5.5 for more safer, and tan 24 degrees. So this, after solving, we will get the required anchorage length is 0.223. Now LR we have determined, that has come 0.255, and this anchorage length has come 0.223. So total requirement is 0.478, whereas we have provided 4.5 meter, which is more than sufficient. Now check the overlap length to see if it is less than the 1.0 meter recommended value. Now जो हमने wrap round के लिए use किया, that is 1 meter, and how much is required we can find out. जो सबसे top layer होगा, that will be more vulnerable for the snatching the this geotextile. So sigma b into sigma h into factor of safety upon 4 tau, because this and again this, so 4 times it will offer the shear stress. SB into sigma h factor of safety 4 times sigma b tan lambda, and जो spacing है, vertical spacing between the reinforcement is 0.5, 4.68 into 0.50 plus 2.60. It has come from this solution of the sigma b, that is sigma h we have calculated k times sigma plus k times q. From there it has come into 1.4 divided by 4 into 18 into 0.50, tan 24 degree. Solving it, 3.458 divided by 15.84, so it has come 0.22 meter, whereas the length provided is 1 meter, which is more than sufficient, hence safe for the overlap length. Now pull out resistance check as per IS 18591 2024. Pulling resistance, जो पुलिंग रेजिस्टेंस होगा, it has to take this out. So 2 times shear stress into anchorage length, into anchorage length, 2 C plus sigma v tan lambda LE, and C is equal to 0, hence 2 it, जो sigma v है, that is unit gamma into Z, unit weight of soil 18 into 6 into tan 24 into 4.245, because this length we calculated, total provided length is 4.5 meter. This active zone length is LR is 0.255, hence remaining anchorage length is LE value is 4.245. So input LE value, so जो pulling resistance will be offered by this geogrid while pulling from this side, the length is 4.245, which is anchored in the stable soil, means resting soil. So it has come 407.2737 kilometers per meter. Check for the factor of safety. So now 15.34 is the pulling resistance will be, tensile strength will be developed in this uh, reinforcement, and whereas available is 407, hence it is 26 times stronger in the pulling resistance, means 26 times more force will be required to pull this geotextile from the resisting zone. With this we have completed how to design wrap-around reinforced earth retaining wall. Thank you.